Hello and welcome! Today, we're going to dig into a huge concept in chemistry that's happening literally all around us, and even inside our own bodies as we speak. So let's jump right into the fascinating world of chemical equilibrium.
So we tend to think of chemical reactions kind of like a race, They have a clear start and a clear finish. The reactants get used up, the products get made, and, well, that's it. Story over. Or is it? What if I told you that for a whole lot of reactions, there isn't really a finish line at all?
You see, the secret is this idea called reversibility. Instead of a one-way sprint to the end, a lot of reactions are actually more like a busy two-way street.
Yeah, so on this street, you've got traffic going in both directions. You have reactants moving forward to become products, but at the exact same time, you have products moving in reverse, turning right back into the reactants they came from. This back and forth is happening all at once. Okay, so if everything is just constantly moving back and forth, does anything ever actually settle down? Oh, you bet it does. It settles into this really cool state of dynamic balance that we call equilibrium. Now, take a look at the top graph here, because this is where it gets really interesting. Equilibrium doesn't mean the reactions have just stopped, not even close. What it means is that the speed or the rate of the forward reaction, so reactants becoming products, perfectly matches the speed of the reverse reaction. It is a perfect balance of speed. And this bottom graph shows you the result of that perfectly balanced speed. Because the rates are equal, the amounts of reactants and products just level off. They become constant. Now, this is a really crucial point. Constant does not mean equal. You could have a ton of product and just a tiny bit of reactant, or the other way around. The key is that the overall amounts are just not changing anymore. I know this can sound a bit abstract, so let's use a super simple analogy to make it all click.
Okay, just picture a bucket. You've got water flowing in from a tap at the top, that's your forward reaction. And at the same time, water is draining out of a tap on the side. That's your reverse reaction. So what happens to the water level if the rate of water coming in is exactly the same as the rate of water going out? Right, it stays perfectly constant. That stable water level, that is your chemical equilibrium. The system is totally active, things are happening, but the overall level isn't changing one bit.
So, if this balance is so perfect, can we mess with it? Can we tip the scales in one direction or another? Absolutely. And there's this incredible principle that tells us exactly how the system is going to react.
It's called Le Chatelier's principle. And let's just say it right because it's a good one. It's pronounced Le Chatelier's. Le Chatelier. Basically, what it says is if you put a stress on a system that's at equilibrium, by changing the concentration or the temperature or the pressure, the system will actually shift its balance to relieve that stress. It's like nature's way of pushing back to find its balance again. So why does any of this matter to you and me? Well, this very principle is actually what's keeping you alive every single second of every day. Let's talk about the chemistry of just breathing.
This equation might look simple, but it is everything. Hb is the hemoglobin in your blood, and O2 is, of course, the oxygen you breathe. They combine in a reversible reaction to make oxyhemoglobin, the molecule that carries oxygen to all your cells. And see those double arrows? That's our sign that this whole process is in equilibrium.